Okay, having a look at question 5 from the General Maths paper 2023, paper number 2. So I've gone ahead and filled in these values here on my network. So we were given the equation t of n is t1 plus 2 outside of n minus 1, which means we are adding 2 each time. So if our t1 is 1, then our t2 is going to be 1 plus 2, gives us 3, and 3 plus 2 gives us 5. So our t1 is 1, our t2 is 3, and our t3 is 5. So I've filled them in here. So we had some where we had 2 lots of t1, so that was 2 times 1. 2 lots of t2, 2 times 3 is 6. t1 plus t2, the 1 plus 3 is 4. Another one of t1 plus t2, 2 lots of t2 is 6, etc. So I've filled that in. Then I drew in my minimum amount to go to each section. So I needed to start and finish at A. So I worked my way around going, oh, well, I've got a 3 here, a 3 and a 5. So I'm going to start with the 3. And obviously I could have gone that way and I would have ended up the same. And then I was looking, going, well, I could go the 2 up to the B because I needed to connect the B. So I could either connect it with the 5 or the 2. So I chose the 2. Then went along to the C because that was the quickest way to connect that. I don't want to retrace any of my steps either. So then I went the 4, the 3, the 5, the 3, and the 3. So that gave me my path that I was going to take. I added up my values and I got 26 kilometres. Then to get my driving time, because I said we drives at 40 kilometres per hour, so the 26 kilometres divided by the 40 gave me 0.65. To get to minutes, I multiplied by 60 and I got 39 minutes. I also had to work out the time it took me to check each site. So I needed to do the 15 minutes there, and there were 8 sites. So the 8 times 15 gave me 120 minutes, which was 2 hours. So that meant I knew I had 2 hours and 30 minutes as my total time. And then I needed to work out if I started at 9 a.m, if I added 2 hours and 39 minutes, what time that would be, and it was 11:39. Next I'm going to have a look at question 6. So for question 6 we've got another question where we're having to do our equation of the line and the line of best fit and looking at the R values. So we've got that we have Lee and we have Tony. We know that Lee is 40. So it says 40-year-old Lee. So Lee is 40. And Tony is 10 years older than her, so he is 50. And it says that 40-year-old Lee works in the industry for which age explains a higher percentage of the account balance variation. So it needs to have the higher R squared value. So what we need to do is work them out for each of them. So we're going to pop them into the calculator. Using our data, we're going to pop those values in. So the 22, 32, 42, 52, 62, 72. Then go back up to the top and we're going to pop in the 7,500. We're going to pop in the 42,000. We're going to put the 98,000 in, the 160,000, the 290,000, and the 400,000. So we now have all our values in there. So we're going to do second data. We're going to choose the 2 variables, L1, L2, and then we will scroll up to look for the R and the A and the B value. So our R is 0.97. Oh, no, I don't need to write that next to Lee yet. So we've got R is equal to 0.97 for that first one, so this is industry A, and our A is equal to 7910, and our B is equal to negative 205520. Then we need to do the same again for the other set of data. So I'm not going to go through that on my calculator again because that would take up a bit of time. But when I do that, we get 0.98 for that one. We get an A value of 9570 and a B value of minus 243440. So looking at that, that means that the B has the higher R value. So that means that we're going to use that one for Lee, and then we're going to use the other one for Tony. So we've got Y is equal to 9570 times the age, take away 243440, and that means for Lee we would get 139360 as her amount, and because we're looking for the current amount for them, that's why we're subbing in her age as 40. And then over here for Tony, we're going to sub in 50 into that equation. So Tony's equation is the 7910 times 50, take away 205520, and that gives Tony 189980. So then we want the difference between them. So we'll do the 189980, take away 139360, and we get a difference of 50,620. So always be careful to work out the full answer, because we have that predicted the difference in their current superannuation account balances. Okay, last question on the paper, question 7. We've got a perpetuity question. So it says, 5 years ago, a retiree invested $100,000 in a compound interest account earning 3.8% per annum compounding monthly, and they now intend to use the balance for a perpetuity, and we've got 4% per annum and $6,000 per year. So for starters, we need to work out what that account is worth now. So what's the amount of that $100,000 that was invested? So P outside of 1 plus I to the N. In this case, our I is the 3.8. We need to divide by 12. So that will give us 0.03. So I think it's just 0.3166%, which then gives us as a decimal 0.003166. Now I'm going to leave them in my calculator so that I can do that. So I'll do my 3.8 divided by 12 and then divide by 100. And I'm going to leave that in my calculator because I'm going to add that to the 1 and then raise it to a power. My N is 5 years, so that will be 60 months that I'm going to do that for. So I'm going to be putting into my formula 100,000 outside of 1 plus 0.003166 to the power of 60. So I'll add 1 to that, raise it to the power of 60, and then multiply it by 100,000. That gives me $120,888.66. The next thing I need to do is check if that is enough to do the perpetuity at $6,000 per year. So what we need is for 4% of this to be equal to $6,000. So if I do 4% of my 120,888.66, I get 4,835.54 as the amount. Now that's obviously not 6,000. The amount that I do need then is if I do the 6,000 over 0.04, I get 150,000. So I can then write a statement that I have 120,888, but I need 150,000. So that current amount that they have is not large enough to finance the perpetuity.